All right, y'all, today we are going to look at how we can take these irregular figures or composite shapes that we've looked at and now kind of get us toward a little bit closer to making sure we can find the area. So the first thing we need to talk about after breaking up the shape is now calculate those missing measurements. So we can compare horizontal sides or vertical sides. So this kind of looks like a three-dimensional backwards L, but we don't have an area formula for that. So what we need to do is to break it up into two or more shapes that we know. So if we go horizontally, remember that's from left to right, kind of like your x-axis. So I could draw right here, and now I have a horizontal line breaking these two shapes up. So this first shape is a rectangle, and this second shape is a rectangle. And it's good that we've identified what these are, because when we are going to find the area in our next couple lessons, we're going to find the area of this rectangle, the area of this rectangle, and then add them together. But we're not doing that just yet. We're first going to go ahead and figure out, once these shapes are broken up, what these missing side lengths are. So the base of this rectangle is 18 feet, the height is 8 feet. We're okay on that. That's all we need to know for that one. But this one, the base is 10 feet, but this whole distance right here is 24 feet. And we only need to know this part right here. So when we break these up horizontally, right, we can see in a rectangle your opposite sides are parallel and congruent. Okay? So this is 10 feet, and we need to know what x was. So maybe we're not finding the area just yet of that one. I'll do a little bit more on that over here to help you out. And we'll see how that's a little bit similar and a little bit different than this one. But if they said, what's the value of x in this shape? Well, in a rectangle, your parallel sides are opposite and congruent. So if this is 10 feet, this is 10 feet. And you can see that this red line that I've made is x plus that 10 feet. And that's parallel and congruent to this opposite side of this rectangle down here, which is 18 feet. So this total distance is 18 because its opposite side is parallel and congruent. And I know a lot of students say, okay, well 10 plus some amount gets me to 18 and do that in their head. But it's good practice to write an equation, because what if this had said 3/4 x and then solve for x? So we'd have to write that equation. Okay, so just to kind of get you in the practice of that. So if we want x by itself, remember we're going to do inverse operations. So the opposite of adding 10 is subtracting 10. That cancels out, and 18 minus 10 is 8. My units are feet. And again, if you go back and check your work, that makes sense, because 8 feet right here plus this 10 feet right here is a total of 18 feet. Okay? So that's how we could figure out that missing measure for this part. Now, we would need to find this part of this rectangle to figure out the area of this rectangle, and that's where the second problem comes into hand. Okay, it's literally the same three-dimensional backwards L, if you will. All right, so if now we're figuring out what the value of y is, well, we can see that this is vertical up and down, and this x was horizontal left to right, so that's why we broke it up that way. That was one way we could see it. So if I go vertical, which is up and down, I can draw my line like this, okay? And again, I have, it looks like a square, but we have to know all those measurements. A square, maybe a rectangle, and another rectangle right there. So, same thing. Your parallel sides are opposite and congruent, so this is 8 feet. Well, this 24 feet is opposite this length right here. So if you guys can see, you have y plus that amount, 8 feet, is equal to that opposite side of 24 feet. Okay? Where some students get confused on this is it said, well, you said horizontal, but why are your lines vertical? And this says vertical, but these lines right here and arrows are horizontal. That's just, we're showing the opposite side lengths are parallel and congruent to those rectangles. That's all that means. So the opposite of adding 8 is subtracting 8. We're trying to get y by itself. And 24 minus 8 is going to be 16. And don't forget your unit, 16 feet. Okay? And again, if you put 16 right here, that makes sense because 16 plus this 8 right here is a total of 24 and opposite and congruent to your rectangle. Parallel sides, are opposite and congruent. Okay, so that's what we're doing. Basically, we're breaking these figures into shapes that we can identify, then use what we know about those shapes to figure out the missing link. So those properties of rectangles, parallel and congruent sides, things like that. Now there is kind of another way, just to kind of show you. You could make this rectangle over here one big rectangle like this, and say this is 18 feet. And if I move all this up to 18, you see this is 18 as well. So this x, you could say, is up here. So x plus 10 equals to that 18. Kind of something else to think about. Here again, we can make this one big rectangle like this. Just trying to show you more than one way to see this. So this 24 feet is opposite sides are parallel and congruent. So 8 feet plus that y gets you that 24. Same thing what we did, just a different picture. Okay, so let's look at these. Again, now we have the same shape, but this 16 inches is horizontal from left to right. So right there is 11 inches. So that means actually, if we go all the way up, we know that A is actually going to be 16 inches because this is parallel and congruent if we were to make one big rectangle. Okay, so kind of see it like that. Here again, this 11 inches right here, break it up, move that up right there. It's parallel and congruent because we're breaking it up into these rectangles right here. So this part would also be 11 inches. Okay? So that way, later on, when we find an area, we can actually know these dimensions. So say, for example, this is 11 inches, this is a total of 16. So we know that this missing measurement right here would be 5 inches. So we find the area of that rectangle. Again, that's going to be coming up. Okay? So now, A is equal to 16 inches, again, because this is opposite, parallel, and congruent. This side right here, we make a rectangle just like that. Opposite sides are parallel and congruent in a rectangle. Then if we want C, well, C is vertical, up and down, so that's why we're going to make our vertical lines. All right, so C is equal to this amount right here. We know this part's 2 inches. Well, here's another rectangle, parallel, opposite sides, parallel, opposite, and congruent. So really and truly, we have this 4 inches, this 2 inches, and C are now opposite sides of this 13. So that means 4 plus 2 plus C is equal to its opposite side, which is 13 inches. Okay, so 4 plus 2 is 6. Combining like terms, we can add the numbers together, but we can't add C. We don't know what that is yet. So subtract 6 from both sides, and 13 minus 6 is 7. So C is equal to 7 inches. Okay, so all these factors that we've talked about writing equations and solving them, combining like terms, properties of rectangles in the past. So that's why we have to make sure we know those rules. All right, so down here we can break this up into a triangle and into a rectangle. And these little dashes you could be using to kind of help guide you. This one right here is just to help guide you once we do break it up to see this height. So for example, if I were to kind of just draw this like this, kind of connect them, we can see this rectangle right here has a base of 20. So its opposite side is parallel and congruent. So this part where it says in represents that little dash. So it's really 8 plus that dashed line in that I colored over so you can see that it's congruent. I'm sorry, that was supposed to be a plus sign. So 8 plus n plus 6, all that distance right there is equal to 20. Okay. What this 10 actually represents was this whole dash. So if you see right here, the vertical if this is 10 and this is 6, well, that really means that this whole distance was 10, so 10 minus 6, that means right here, that height of the triangle is 4. So we'll come back to that later on. Right now, we're just figuring out what n is, okay? But that's what that 10 represents, was that total distance right here. But right here, this, let me use that color again. I did a vertical, this distance is equal to this distance. So this total dashed line was 10. 10 minus 6 is 4. So that's going to come in handy later on when we solve that area. But right now, we just wanted to figure out what n was. So we're going to combine like terms. 8 plus 6 is 14. We can't add the n to it because they're different. Then we subtract 14 from both sides. And n is going to be equal to 6 meters. And here again, you always want to double check. 8 plus 6 is 14. 14 plus 6 gives you that total distance of 20. So again, we're just first breaking up into shapes that we know, finding the missing measurement if we need it, and then in our next lesson, we're going to go ahead and start finding the area of that. So if you don't have those missing measurements, we need to know those so that we can find the area.